Hello, my esteemed viewers. In this tutorial, we will clearly explain the sorting manipulation in general and bubble sort in particular. And you should be knowing that these are all the following manipulations that are implemented in an array only to retrieve some kind of an information: initialization and duplication, accumulation, reversing, arithmetic operations on the array, sorting, searching and merging. In today's discussion, we will discuss about sorting and how to implement sorting and in general, and how to implement bubble sorting in particular. And arrays are also called as lists. An array is a list. So if a list is in a haphazard order, it may be a list of fruits, list of names, list of integer numbers, list of salaries or whatever. If it is in a disorder, one's first impulse is to arrange that list either in ascending order or in descending order, because it becomes a great deal easier to look at an ordered list from top to bottom or from bottom to top. And also by sorting, several other exercises in array will become simply very clear and very easy. Searching becomes easy if array is sorted. Let us say we are searching for a person with a particular name in among 1,000 names. If you arrange it in ascending order or alphabetical order, searching becomes very easy. It holds good even for numbers also. Searching becomes very easy. In an unsorted array, searching becomes very tough because you need to compare all the elements. Finding first three toppers, let us say, in a list of students, having a particular marks list in a particular subject, it becomes very easy to find the first three toppers. In the absence of sorting, in the absence of a sorted array, sorted list of numbers, it takes hell out of us to find first three toppers. Finding in the same token, finding bottom three slow learners is also very easy if we sort the list of numbers, list of marks, and top 10% of the class and also bottom 10% of the class. It is very easy to locate and very easy to make a separate list of top 10% of the students of the class and bottom 10% of the students of the class. This program checks, just checks whether a given array of n elements is arranged in ascending order or descending order or unsorted or having all the elements being equal. And it will also appropriately print messages. And this has to go, but anyway, in order to find out whether an array is ordered, and this program is not about implementing any of the algorithm. This is a very general program wherein the program will find out for a given array whether a given array is ordered or not. If an array were to be like this, let us say 1, 2, 3, 4, 5, it is sorted in ascending order. And in order to do this, this is to be compared with this, and this is to be compared with this, and this is to be compared, and this is to be compared. If there are 5 elements, 4 comparisons are a must. In the same token, if the array is in descending order, 4 comparisons are to be made. And if the array is unsorted, okay, and it will be one of the elements will be greater than the other element, and the next element will be lesser than the previous element, and these things are to be checked. Okay, therefore the program goes like this: integer a 100, this we have declared, I to run the loop, n to ask the user as to how many elements he or she wants to enter, ascending order equal to 0, descending order equal to 0. These two are flags. I think when we discussed about checking the prime numbers or listing the prime numbers from a range, from a input range from a lower bound to upper bound, we have told or we have understood that whenever too many entities are to be checked in a program, we need to have a flag. Here we have to come out whether an array is in ascending order or in descending order. Therefore, we need 2 flags. In the beginning, we are going to assume that array is not in ascending order and array is also not in descending order. This is an assumption. Okay, anyway, the things are ready. Enter the number of elements. The user will enter number of elements which will be stored in n. Enter the elements one by one. He will enter one by one. So elements will be into the memory. and checking is done now. For I equal to 0, I less than n minus 1, because if there are n elements, there need be only n minus 1 comparisons. Okay, this is in order to compare n minus 1 comparisons, I plus plus. Okay, if a of I, that is the previous element, is greater than the next element, if the previous element is greater than the next element, then descending equal to 1. That is the situation is something like this. Situation is something like this. And if a of I is lesser than I plus, and in every cycle, if this comes true, the array must be something like this. Then descending, this flag will remain to be 1. On the other hand, if ai, that is the previous element, is lesser than the next element, then ascending equal to 1, then the situation will be something like this: 6, 5, 4, 2. In all the cycles, all the 3 cycles, the ascending remains to be 1 and descending remains to be 0. And in a typical case, something like this: 2, 4, 2, 4, 3, 1. Let us say the situation is like this. In the first cycle, if a of I less than a of I plus 1, so ascending becomes equal to 1. In the second cycle, a of I is greater than a of I plus 1. Okay, therefore descending will become equal to 1. And in the next cycle, so when it goes over here, in the previous cycle, ascending was equal to 1. In the next cycle, descending was also equal to 1. And when the control comes over here, there is a peculiar situation where ascending is also equal to 1, descending is also equal to 1. Okay, ascending became 1 in the first cycle, descending became 1 in the second cycle, and when it goes for checking, when it comes for the third step, this becomes true. This becomes true if and only if the array is not sorted. Therefore, immediately array is not sorted will be printed, and it will be held for a while on the key till you get a character and exit 0. So it's a force exit. So in order to operate with this function, we need to include process.h, which has been done in the program. There is no fun in going to iterations again and again, because it has been proved that the array is not in order. You think of an array which is very big in nature, very big in size. Therefore, unnecessarily we have to go again and again, and that is not the logic also. So, in a particular cycle, ascending will be equal to 1 and descending will also be equal to 1. Both of them will be equal to 1 if and only if array is not sorted. So now we will come out of the for loop. Okay, if that doesn't happen, if the control will never go out, either array is in ascending order, the array must be in descending order, or all the elements must be equal. So we will hold that key. Then we will compare. If as ascending equal to 1, the array is in ascending order. So if the array is truly in ascending order, ASC will be equal to 1 will be preserved in all the cycles. Else if descending equal to 1, okay, if the array is already in descending order, definitely descending DSC as a flag will be just held at a value of 1 for all the cycles. Then we will be writing array in descending order. Otherwise, if ascending is not equal to 1, descending not equal to 1, then it should have been not ordered. Okay, if it is not ordered, it will have been published, it will have been echoed on the screen earlier itself. If that doesn't happen, then all the elements must be equal. We have made 4 runs. In the first run, we have taken 4 elements, and we have enter the elements, and it is in ascending order. And in the second run, it is the array elements are in descending order. In the third run, it is not in order. Not sorted. And in the fourth run, all the elements are equal. Now, we will explain a famous algorithm called as bubble sort algorithm. Okay, right. Bubble sort algorithm is a simulation of a physical process of the bubble that rises, an air bubble that rises in a water column when it is entrapped. Okay, whenever it rises something like this. Okay, it replaces a heavier molecule of the water and it replaces heavier molecule of the water, and it rises just like this in a water column, in a vertical water column. On the other hand, if you drop a mercury bubble, it will descend down because mercury is heavier than the water molecule. Okay, so this is analogous to the things in ascending order, and the latter example is analogous to the things in descending order. Therefore here in this particular algorithm, all the elements will be compared with the rest. Now we will take an example. Okay, we will present an array. We will present an array with 4, 3, 2, 1. That is, the array is in ascending and descending order, and we will ask the algorithm to arrange this in ascending order. And this is the worst case scenario for the algorithm. Algorithm has to do a lot of work. Okay, so 4, 3, 2, 1 is let for comparison. So we say first iteration is started. 4, 3, 2, 1. 4 and 3 is compared. 4 and 3 is compared. It will be swapped. It becomes 3 and 4. Now 4 and 2 will be compared. It becomes 2 and 4. Okay, then 4 and 1 will be compared. It becomes 1 and 4. So 3, 2, 1, 4. After the completion of the first iteration, there will be 3 passes or 3 comparisons. Okay, if there are 4 elements, I repeat, if there are 4 elements after the first iteration, there will be 3 passes or 3 comparisons. If there are n elements in the first iteration, there will be n minus 1 passes and therefore n minus 1 comparisons. Anyway, this is a partly sorted array. So 3, 2, 1, 4 will be the input for the second iteration. So 3, 2 will be compared. It becomes 2, 3. Okay, it becomes 2, 3. And 3, 1 will be compared. It will become 1 and 3. And there is no need to compare 3 and 4 because 4 is already bigger than 3 and 3. So okay, one should notice here, however may be the length of the array, whatever the number of elements in the array, if you are arranging things in ascending order using bubble sort, the greatest of the biggest of all the elements will be shown its seat. It will come to the last position. Therefore, this will reduce the at least one comparison in the next iteration. So here it happened literally. So 3, 2 is compared, one comparison, it becomes 2, 3. 3, 1 is compared, it becomes 1, 3, and there is no need to compare 3 and 4. Therefore, what emerges in the second iteration is, 2 comparisons and 2 passes. 2 passes or 2 comparisons. And in the third iteration, let us see what happens. Once again, after the second iteration, we got a partially sorted array because it is 2, 1, 3, 4. So 2, 1, 3, 4 will be let for comparison in the third iteration. 2 and 1 is compared, it becomes 1 and 2. Okay, rest of the comparisons need not be made because it is already in the sorted order, in ascending order. Therefore, in the third iteration, it requires only one pass. Therefore, if there are n elements, bubble sort requires n minus 1 iterations compulsorily. And as the iteration progress one after the other, there will be reduction in the comparison. For example, in the first iteration, there will be n minus 1 comparisons. In the second iteration, there will be n minus 2 comparisons. In the third iteration, there will be n minus 3 comparisons. That's all. Okay, one comparison is going to reduce, okay, iteration after iteration, and so also the number of passes. So we will take this clue from here and we will write the crux of the program, crux of the algorithm, or gist of the algorithm, or main logical portion of the algorithm. It needs 2 for loops. One for loop to run the iterations, the other for loop to run the passes. So this first outer for loop is set to I equal to 0, I less than n minus 1, I plus plus. It generates n minus 1 cycles. And for j equal to 0, j less than n minus 1 minus I, j plus plus. This generates passes. You should clearly see over here, j equal to 0, j less than n minus 1 minus I. Okay, in the first iteration I brings 0, so it becomes n minus 1. In the second iteration I brings 1, it becomes n minus 2. In the third iteration I brings 2, it becomes n minus 3. So progressively there is a reduction of passes. But in the first iteration, n minus 1 passes must happen. Okay, so it generates passes that progressively reduces by 1. And this comparison is made. If a of j, that is the previous element, is greater than a of j plus 1, and if you are arranging things in ascending order, this should not be the case. The previous element should be lesser than a of j plus 1. If a of j, the previous element, is greater than a of j plus 1, then swapping needs to be done. And if the things are, if the problem is about arranging things in descending order, you will just change this relational operator. If a of j is less than a of j plus 1, then swap. Okay, now we are arranging things in ascending order, therefore this holds the key. This is the logic. Therefore a of j is greater than a of j plus 1. We will hold a temporary variable and we will store a of j. So a of j gets vacated. A of j will now contain a of j plus 1, or a of j will be overwritten by a of j plus 1, and a of j plus 1 becomes empty, or a of j plus 1 is amenable for overwriting. So a of j plus 1 will hold whatever the temp contains. So wherever this situation exists in the array, okay, and there are swappings, and this is the main gist of bubble sort, main logic of bubble sort. So we will complete the program now. Include all these things are done. Integer ne, number of elements, I and j, loop indices, array 100 elements, temporary variable. How many elements? The user is questioned, and he will enter, say, whatever the number of elements, and he should take a precaution in such a way that he will enter the number of elements lesser than 100. Enter the elements, or he will start entering the elements one by one. Array before sorting, this is also printed, because in order to have whether the program is effective. Okay, array before sorting. Now bubble sorting takes place now. Okay, this is the for loop for generating iterations, and this is the for loop for generating passes. And if array j is greater than array j plus 1, and we will do this swapping, you look here, this for loop is controlling only this for loop. Okay, therefore the number of statements under the ambit of the outer for loop is only one for loop, and number of statements under the inner for loop is only if statement. Under this if there are 3 statements, therefore only these 3 statements have been given flower braces. Okay, so therefore there is no need to put a flower brace over here and flower brace over here. For this is the only one statement. For this is the only one statement. For this there are 3 statements. Now upon completion of these 2 double arrays, double for loops, okay, number of iterations, after the completion of n minus 1 iterations or n minus 1 iterations, what comes out is the sorted array. Okay, which gets printed over here. Printf array after sorting I equal to 0, I less than any, I plus plus, percentage 4d, because it will be printed in a row with a gap of 4 spaces. Okay, right, and it will be one run is also done. One output is printed over here. How many elements? 7. These are all the elements. The array before sorting is this, and the array after sorting is this. Okay, so we will complete, and we will just take up selection sort in our next program, next tutorial. Until then,